Hi to everyone, welcome to NCC channel. My name is Naresh, chemistry lecturer. Today I would like to discuss top 20 trends in S block elements. These are most important in exam point of view. Please listen carefully. First one, we have to find out density order. Lithium, sodium, potassium, rubidium, cesium. They are given first A group elements. We have to find out order of density. Now, already you know that in a group from top to bottom, size increases, at the same time mass also increases. If the mass is more, density is more. Now cesium has more size and it has more mass. Now cesium has more density, followed by rubidium, followed by potassium, followed by sodium, and followed by lithium. But there is a small change in this order because that is sodium has more density and potassium has less density compared to sodium has more density compared to potassium, because in potassium there is abnormal change in volume. If the volume is more, density is less. That's why the density of potassium decreases compared to sodium. Now the correct order is cesium, followed by rubidium, followed by sodium, followed by potassium, followed by lithium. Now sodium has more density compared to potassium. Now coming to second question, we have to find out a reducing character. The given first A group elements lithium, sodium, potassium, rubidium, cesium. We have to find out order of reducing character. Reducing character depends on ionization energy. If the ionization energy is less, reducing character is more. When we are moving from top to bottom in a group, size increases and ionization energy decreases. Now cesium has more size and it has less ionization energy. If any atom has less ionization energy, it can release electrons easily. Now it has more reducing character. Now cesium has more reducing character, followed by rubidium, followed by potassium, followed by sodium, and followed by lithium. But there is a small change in this order, that is lithium has more reducing character because lithium is the smallest size and it has more hydration energy. And it can release electrons easily. Now the correct order is lithium has more reducing character, followed by cesium, followed by rubidium, followed by potassium, followed by sodium. This is the reducing character order. Now coming to third question, we have to find out order of ionic radii in water. They given lithium, sodium, potassium, rubidium, cesium ions belongs to first A group elements. Already you know that in a group from top to bottom, size of the atoms increases and also size of the ions also increases. But if the ions taken in water, what will happen? Already you know that lithium has more hydration energy. It can attract the more number of water molecules around its ion. Lithium can attract more number of water molecules around its ion because of more hydration energy. That's why the size becomes more. When we are moving from lithium to cesium, the hydration energy decreases. That's why it cannot attract water molecules more effectively. That's why the size does not change. Now when we are moving from lithium to cesium, the ionic radii in water decreases. The ionic radii in water decreases. Now coming to question number 4. Given first A group elements ions, lithium, sodium, potassium, rubidium, cesium ions, and we have to find out the order of electrical conductivity or molar conductivity in water. Already in third question we have discussed the size of the ions in water. Lithium has more size, followed by sodium, potassium, rubidium, cesium. Electrical conductivity is directly inversely proportional to size of the ion. If the size of the ion is more, electrical conductivity is less. If the size of the ion is less, electrical conductivity is more. Now in these ions, the size is less in cesium ion. So size is less, electrical conductivity is more. First cesium ion more electrical conductivity, followed by rubidium, followed by potassium, followed by sodium, followed by lithium. This is the electrical conductivity order. Now coming to question number 5. Next trend is reactivity with hydrogen. Reactivity with hydrogen. Already we know that hydrogen can react with first group elements, can form lithium hydride, sodium hydride, potassium hydride, rubidium hydride, cesium hydride. Already we know that the size of hydrogen is very less. The size of hydrogen is very less. When we are moving from sodium, lithium to sodium, the size is increasing. The size is increasing. So the small size atom can react with the small size hydrogen atom can react with the small size atom very effectively, but the small size hydrogen atom cannot react with big size atom effectively. So this small size atom cannot react with the big size atom effectively. So that's why the small size atom can react the small size atom very effectively. So the order is like this. Now coming to question number 6. Reactivity with water. We have to find out the order of reactivity with water. They are given first group elements lithium, sodium, potassium, rubidium, cesium. Already we know that in a group from top to bottom size increases and ionization energy decreases. If the ionization energy decreases, reactivity with water increases. Now coming to 7th one, melting point. We have to find out order of melting point given lithium, sodium, potassium, rubidium, cesium. So we have to find out the order of melting point. Already you know that melting point means the temperature at which a solid converts into liquid. That is called melting point. So this belongs to first A group elements. That means it contains only one valence electron. Now when we are moving from top to bottom, size increases. Now cesium has more size. If any big size atoms cannot hold properly with one valence electron, but the small size atoms can hold very effectively with one valence electron. Now melting point is lithium, followed by sodium, followed by potassium, rubidium, cesium. Now coming to question number 8. We have to find out basic nature of hydroxides. First one, lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. Lithium, sodium, potassium, rubidium, cesium. Size increases when we are moving from top to bottom. Size increases. Now this is the hydroxide ion. Now these blue circles indicates lithium, sodium, potassium, rubidium, cesium. This pink circle indicates hydroxide ions. Here in cesium hydroxide we can see the size difference is more. If the size difference is more, lattice energy is very less. In that time it can break these molecules break easily. These molecules break easily with ions. In that time it can produce hydroxide ions very easily. Now if any substance produce hydroxide ion easily, so that has more basic nature. We can say that the substance has more basic nature. Now cesium hydroxide has more basic nature, followed by RbOH, followed by KOH, followed by NaOH, followed by LiOH. Now coming to question number 9. LiCl, LiBr, LiI. Lithium chloride, lithium bromide, lithium iodide. We have to find out covalent character. Already I given one code, that is CA, chartered account. So covalent character is directly proportional to size of anion. If the anion size is more, covalent character is more. So Li plus Cl minus, Li plus Br minus, Li plus I minus. So cations are same, but anions are different. Now in these anions, which anion is more size? Iodide ion is more size. Now covalent character is more, because covalent character is directly proportional to size of anion. If the anion size is more, covalent character is more. Now lithium hydride has more covalent character, followed by lithium bromide, followed by lithium chloride. Now coming to question number 10, we have to find out order of ionic character. Given BeCl2, MgCl2, CaCl2, SrCl2, barium and chloride, BaCl2. Now already I given one code, that is intensive care IC. Ionic character is directly proportional to size of cation. Size of cation. Here anions are same, but cations are different. Beryllium, magnesium, calcium, strontium, barium. When we are moving from top to bottom, the size of cation increases. Now barium has more size. If the cation size is more, ionic character is more. Now BaCl2 has more ionic character, followed by strontium chloride, followed by calcium chloride, followed by magnesium chloride, followed by beryllium chloride. This is the ionic character order.